Shapley value is not a new concept. The original Shapley paper was written in 1953. So when you think about it, Nirja, 2 years from now, this will be, 70 years old, the original Shapley Value paper? I mean, it is really quite an old piece of paper. And there have been a variety of people who've written about Shapley Value, almost all of them economists. Shapley Value is a concept in game theory. It can be used to assess the contributions of multiple players to a group project, where the group project is perceived as a game. The original assumptions behind Shapley Value, the game was supposed to have a finite number of players. It was supposed to be a cooperative game, which means the agreements between the players are possible, the agreements are enforceable. Total value of the game is set before the game is played. Side payments among the players are possible. So if you have this kind of a cooperative game in place, the Shapley value is a unique solution to the game that satisfies 4 axioms. And let me talk to you about the axioms. The first axiom is symmetry. If 2 of the players are identical, they get the same treatment, they have the same value. Axiom number 2 has to do with dummy players. If you add a player to the game and the total value of the game doesn't change, the value of the player is 0. In other words, the player doesn't matter to the game and can be discarded. I assume the same is true with the dummy player. If you took a player away from the game and it didn't change the coalition's worth, again, the player's value is 0. All right, axiom 3, efficiency or Pareto optimality. The sum of all the players of the game has to equal the worth of the grand coalition, which is the total amount of the pie. In other words, once I work out the value to each of the players, when I add that up, it has to totally exhaust the value of the pie. And that's the efficiency axiom. And the lastly is what's called the additivity axiom, which is if you have 2 games, the value of 2 games is the sum of the value of the 2 games. So if one game's worth 10 million and the second game is worth 5 million, the 2 games added together are 10 plus 5 equals 15 million. So under those rules, the sort of rules I specified for what a cooperative game looks like, and then the 4 axioms of the game, symmetry, dummy player, efficiency, and additivity, here's what the Shapley value is. Shapley value is the expected marginal contribution of the ith player in a random coalition. In other words, if you had random coalitions of the players, what's the expected marginal contribution of the ith player? And then you average that over all the possible coalitions. The Shapley value is the average marginal contribution of the ith player to the game. So in other words, it's kind of a really cool idea. If say you got 5 people playing the game, you want to think of all the possible combinations and permutations of those players joining the game, and you figure out what happens when you add the next player to that combination. And then you do it in another combination, and you do it in another combination, you add them all up, and you do the average of these. Now, let me say that economists have had almost 70 years to play with this, and they have relaxed a lot of the assumptions of the game. And they have looked at the importance of the different axioms too. And what I can tell you is what they've discovered is they can still get a Shapley value out of here, even if you start relaxing some of these assumptions of the game. You allow, for example, uncertainty where you don't really know what the total value of the game is going to be worth. But think how cool this is. You're talking about cost contribution arrangement or a cost sharing arrangement in R&D, where you've got a group of players coming together and they're going to engage in R&D. Each of them is putting something in on the table, and they're going into a game where they're going to split up afterwards. We could do this to estimate Shapley value to figure out what the contributions of each of the parties are to the game here. So this is, I think, a really cool idea. And what it does, I think, is it actually picks up a couple of things. One, it allows for DEMPI intangibles, really broad intangibles. You think holistically about intangibles, not just hard commercial ones that are protected by intellectual property rights, but you take into all kinds of things like trade secrets, learning by doing, the value of a team that's been in place for a long time. And the way you get at it is you say, let's pull that entity out or add that to the coalition and see if we can figure out what they do and then average across all of these to work this out. The cool thing I think about this is most people would say that's fair. You can get a good estimate of what each party brings to the table, averaged over all the possible all the possible players and all the possible games. That is, over the lifetime of that game, a fair way to allocate the profits from joint distribution and exploitation of an intangible among the entities in an M&E group. So one of the things I realized when I started working on this paper with the three neuroeconomists was this is a really cool way to solve the conundrum of what value creation means in the transfer pricing guidelines. There's a lot of people who think the idea of value creation is really fuzzy, and we can't get a handle on that, and we really can't measure DEMPI contributions, and yet here we really can. And one of the things I think, and this was something that Yves Hervé realized, and I think he's quite right, you could take existing transfer pricing benchmarking studies, the standard stuff that transfer pricing professionals do all the time, and supplement those to calculate the Shapley value. So you could, in effect, use Shapley value to fine-tune existing applications of the cost plus and resale minus methods and do that. And in the case study that's in the paper, that's exactly how they did it. What the paper was it was done for a German multinational that had a parent, I think, in Switzerland, and the entity was actually selling in Germany, and the product was being made, I think, in Belgium. So the parent was in Switzerland, the manufacturer or somebody was in Belgium, and the actual distributor was in Germany. So what NERA actually did in this particular case was to take the existing transfer pricing studies, and they were doing this specifically from the German subsidiary perspective because it was a dispute with the German tax authority. And they were able to figure out how you should adjust this to figure out how much really did belong in the German distributor versus how much belonged in the principal, which was in Switzerland where the IP was, or belonged in the manufacturing entity, which was in Belgium. And what happened is the German subsidiary actually got a bit more than it would have gotten as a routine entity, but nothing like what the tax authority said it was expecting to get. And then my understanding is the tax authority actually bought this. Now, if you work through the paper, what you see is us working through all the combinations here. And it starts with the sort of thought experiments about what does traditional transfer pricing give you. And then it says, okay, now let's think about this from the thought experiment of what if you're an entity alone and you have to go and contract out for all the other functions. So I'm the manufacturer and I need to contract out to the distributor and I need to contract out for the R&D. Or I'm the R&D entity and I need the manufacturer and the distributor. Or we're two and we have to contract for the third. And we do that around. And then lastly, we're all together. So with three entities, there are 7 possible combinations. Now, I assume you will think of the same thing that occurred to me. And there are really 2 things. Think about scaling this up. So for 3 entities, there are 7 combinations. For 4 entities, somebody who's a mathematical wizard can tell me how many combinations there are, but clearly as the number of entities in the group go up, they are going to rise. So I mean, scaling this up, I think is an interesting question. The other, of course, is this was done with one government, the German tax authority. But the nice thing I think about it is, suppose you were doing this in the context of an APA, an advanced pricing agreement, and maybe a bilateral APA where you had 2 governments and you were interested in doing it with 2 and you still had a third. I think there's possible ways to do that. And then, as I said to Nirja, This was clearly done for intangibles. I don't think anybody has ever done this for digital services, but figuring out digital transactions, like, for example, if you look at our paper on Internet of Things, which I believe you're reading for today also, what's the value that IoT brings to the group? How do we assess that? In the paper that Nirja and I wrote with Srini Lalapet, we looked at all the existing transfer pricing methods and found them all somewhat wanting. But I think we didn't think about Shapley Value as a possible way to do this. I guess what I'm saying is I like the concept of Shapley Value. I also, frankly, really like the concept of using value creation as a way to allocate the group profits that also takes into account synergies between the parties. To me, that's more what the underlying spirit of the transfer pricing guidelines and the arm's length standard was all about at the beginning. With the mathematical capabilities we have now, I suspect it's doable to scale this up from larger players. In other words, larger multinationals where you've got, this is, more than just a manufacturer, an IP, and a distributor here. I'd love to see it done, for example, for a multinational doing IoT, or what 3D printing would bring to the table. I mean, think how cool this would be to do some more papers on here. So let me say we were not the first to write on transfer pricing of Shapley Value, and there have been a variety of other, mostly, frankly, NERA economists. I think partly because NERA has so many PhDs in economics, and they would be familiar with game theory and with the concept of Shapley Value. And so there are other papers that have moved on this, and they're cited in some of the reading, and I hope you would look at those too. So let me talk to you a little bit about what they've done. They've done a little bit of work on cost contribution arrangements, for example, and hubs. And I think there's a big contribution to be made here in thinking what, when you integrate, whether it's a technology or it's, your IT or your back office or your front office functions, you're doing it to get integration economies. What if you have, for example, a cash flow? And what if you do this and you do it in financial services where you set up a financial hub, and the financial hub actually is designed to, it has an entity in it that is supposed to manage the flows, and it does all the foreign exchange transaction and acts as a bank. Could you use Shapley Value to allocate the returns among the members of the group? I actually think this now, maybe in a world of big data with much faster computers, has the opportunity to do much more sophisticated transfer pricing. And I hope you think so too, and that maybe I might interest some of you to continue some work in this area. And I'll stop here and pass it back to Nirja.
Thank you so much, Professor Eden. I think as you were speaking, there were, I don't know how many questions that arose in my mind around Shapley Value and residual profit split methods. Mm-hmm. Are they corroborative, supplemental?
Common. Yeah, what's really cool about it, Nirja? I think there's a lot of overlap. Mm-hmm. The one thing, the big difference is in the residual profit split at the beginning, remember, you decide the pool of the profits. You have a fixed pool, so that works. You know the entities that are involved. Now, those are decisions that have to be made. So you influence by picking the pool and the entities, right? Having done that, the next step is the problem one. The next step says which entities are routine and pay them a routine rate of return. Instead, I think what Shapley Value does is it says no entity is routine. All entities have the potential to add something to the group, either because the putting them together creates synergies. And it does, of course. Think about it. The sine qua non of the multinational is the fact that by going in-house, it avoids transaction costs. Mm-hmm. So at least it's saving in transaction costs, although you will have governance costs. So, transaction costs go away, but governance costs come in terms of managing that group, right? But the bottom idea, that simple residual profit split method still holds, except now we don't pigeonhole an entity as saying you're routine. You might pigeonhole them in the sense of saying you're going to get at least something, right? Some share of this. And then in what's left in the residual profit split historically, that was given to the so-called non-routine entities, and they got the ups and downs. Now, let me just say one other thing I think that means. And the simple thing is to talk about the Northern Telecom case. When Northern Telecom went bankrupt, it had a transfer pricing policy based in place on a worldwide basis that was a residual profit split. Entities were defined as routine. The distribution entities were defined as routine. The manufacturing entities had been routine and then was sold off. So manufacturing was contracted out to Flextronics, if I remember. I'm pretty sure it was Flextronics. So then all that were considered to be non-routine were the R&D entities. And so what happened when the firm went bankrupt, there was a pool of profits to be allocated. The routine entities were locked into a routine rate of return, which they got. And when you took the routine return off from what was left of the M&E, all the non-routine entities got losses. So in effect, by using a residual profit split method on a multinational that had gone bankrupt, the routine returns did not, or let me say it the other way, the routine returns exhausted the amount of the pool of the cash, and the non-routine entities got significant losses. And so you were better off, frankly, if you were routine in that day. And much of the big fight then was about who was going to get the value of the assets that could be sold, because there were negative numbers for allocation of the money. Any entity that's using a residual profit split, you're in some sense blessed and cursed if you're labeled routine, because you're blessed because if things go bad, you get your routine return. You're cursed in the sense if you're routine and things are up because you're locked into that low one. So it partly depends upon how risk averse you are. If you are very risk averse, you'd like to be routine and get your 5% or 10%. If you like risks, you'd much rather be in the strategic group and take your ups and your downs, I think. But the general idea behind Shapley Value still works with the residual profit split method. It just basically says nobody is automatically routine and automatically gets a fixed rate of return. I don't know, it's kind of a long-winded explanation, but I hope it's
terrific. Yeah, terrific, Lorraine. I would love to see Shapley Value replace revenue allocation keys in pillar one, frankly. Absolutely. Because that would be closer to an arm's length principle than what we currently have. So that's certainly the case. And then the other thing that crops up in my mind is about financing. And in the 2017 TPG, there was plenty on control of risk and financing, and whether it's routine or strategic. So it seems to me that Shapley Value can accommodate not just the DEMPI of IP, but also the financing of IP in its different forms.
Now, let me just say that when we wrote the paper, we were very focused on DEMPI. I think it needs to be expanded to entrepreneurial roles and risks. I've always been big on the idea of entrepreneurial roles and risks, and I think any entity has the potential to play an entrepreneurial role within the multinational group. Even a distributor can play that. And let me just give you a simple example. Some firms grow by acquisitions. Those that grow by acquisitions, the entities that got acquired probably already had entrepreneurial roles and were assuming entrepreneurial risk. And just because they got acquired didn't mean they lost them, right? And so I'm very much a believer that entities within the group, and not just cash pools, although cash pools are an obvious example of this, and hubs can take on entrepreneurial roles and risks in a group too. So can principals, as a regional headquarters. They clearly perform entrepreneurial roles and risks. Maybe I should say that. My starting out by saying the principal and sort of suggesting was not meant to imply that the principal didn't take on entrepreneurial roles and risks. I guess what I'm saying is you can't label an entity now. You need to allow for the fact that an entity anywhere on the value chain might play not a significant role. And what I mean by that, I don't think it can make a de minimis contribution. I think you have to take those out. So what you have to say is it an entity that when added to the group materially affects the pie? By bringing that inside the MNE group, is the pie's value larger? And so, in other words, remember I mentioned about Northern Telecom. Northern Telecom clearly figured manufacturing was not an essential part of the telecom firm. And so it sold the manufacturing off to Flextronics. I don't know whether it was right or it was wrong. But all I'm saying is when firms sell off entities, they're clearly making an assessment that either the entity is a dummy player or that in selling the entity, they reap the cash that enables them to do something else they want to do with that money. So I think it's really, I like the concept a lot. And I've always liked Shapley Value. I certainly knew about it for a long time. I never thought it was really practicable. And now I'm starting to think that in conjunction with existing transfer pricing methods, it can be a fairer solution all around to all parties. And that's what you want. Partly, I mean, it's meant to be fair, but I think it also needs to be perceived as fair. The group is never going to stay together if entities within the group feel they're being taken advantage of, right? So the perception of fairness is also as important in some sense as the actual fairness.
And tax authorities certainly want fair shares. So
yes,
anything that helps us find better ways to calibrate, to measure it, is of tremendous value. So, Lorraine, thank you so much. This was wonderful. This was really a wonderful contribution to the class. We appreciate it. And this is just the tip of the iceberg.
Dr. Srinivasan, it is always a pleasure to work with you.
All right.
And I'm hoping that some of the stuff I've talked about Shapley Value today might induce you to think about we writing a paper together on Shapley Value in digital.
Well, I'm absolutely.
Hubs. I think hubs are there too. Really, we could write about hubs and digital.
Yeah. And for the class, this is very important for many reasons, one of which is that it appears in your assignment. So make sure that you do the required reading, which has been posted to Canvas under week 3. So please go through that. And you can always reach Professor Lorraine Eden. I think I'll put her email down there. You can always reach her with questions or comments about the paper. Thanks
Love to receive comments. This is the first time I've presented it. So the first time around, you can make a variety of mistakes, but so I'd love to have your comments.
Thank you.